It's all about aligning the incentives of the three core users of the platform. You have miners who want more adoption. They want a bigger network doing more transactions a second. You have users who don't want to pay high fees. They want high security, they want decentralization, they want trustlessness, they want openness, but they also don't want to pay fees. And businesses who want to know that if they start using this platform and they start congesting the network because, think Cryptokitties. It launches and then Ethereum gets clogged for a week. They want to know that the network can grow to support the throughput that they now need because they found their product market fit.
Welcome to the HackerNoon podcast. I'm your host, Trent Lapinski. In this episode, I interview Will Martino, the CEO and founder of Kadena, and their head of marketing, Tony Pham. In this episode, we talk about what they're working on, which is a new programming language for smart contracting, as well as scalability and use cases for enterprise blockchain solutions. This is an amazing episode, so please stay tuned.
This episode of HackerNoon is sponsored by Digitalocean. Join a community of over 3.5 million developers learning how to build and scale high-performance web apps on the simplest cloud platform. With a flat pay-as-you-go pricing structure and monthly caps across all global data centers, DigitalOcean makes it easy to get the computer resources you need without the billing surprises you get from other cloud providers. Discover why developers love DigitalOcean and get started with a free $100 credit at do.co/HackerNoon. Full-stack developer Austin Pocus.
We're using it to host a discourse site. So basically they give us a machine and we run a Dockerized instance of discourse on there. Gets a few clicks and discourse is ready to rock. With DigitalOcean, they have a marketplace where you just click, I want discourse, you provision a droplet, and you're good to go.
Welcome to the podcast. I'm here with Will and Tony. Hey guys, tell us a bit about what you're working on.
Hey, thanks for having us, Trent. I'm Will Martino, co-founder and CEO of Kadena. Kadena is focused on building a blockchain platform that can really help people who have this vision for changing the world have the tools they need to depend on to be able to take that vision into production. I think that a lot of people are underserved by these amazing visions of this decentralized future, but when they go to actually put rubber to road, they have trouble. So Kadena is focused on having a smart contract language that's easy to use and incredibly safe. It's good for everything that you want to do with the blockchain. It's actually meant for people who are technical and understand their domain, but may not be engineers. And it also has formal verification because those same people deserve the same level of security that you get for aerospace engineering. This language is meant to also be embeddable because we need to have a standard for smart contracts. They're incredibly expensive systems to build and to make safe. And Pact, our smart contract language, is one of these. Right now it runs on our private blockchain, Scalable BFT, and our public blockchain, which is now in testnet, called Chainweb. It's a braided, high-throughput proof-of-work protocol.
Awesome. And Tony, what about yourself? What's your role at the company and what are you contributing?
Sure. My name's Tony Pham. I'm head of marketing at Kadena. I actually just moved to New York from San Francisco at the end of last year. So got a wintry welcome. And then a lot of what I'm working on is helping to make the awareness and the engagement of our tools be more accessible. I like to say if someone like me can already start to be playing with Pact, it's possible for anyone.
Awesome. So, Will, I've got to ask, so, you've got quite an extensive background. Can you go a little bit into how you got into this space and some of the things you've worked on in the past?
Yeah, sure. So I like to say it's probably one of the weirdest introductions to crypto of anyone that I've met. And that's because I initially started working on blockchain-related projects at the Securities and Exchange Commission. I was there as the lead engineer for a quantitative R&D group that was based out of New York. I was building the forensic data analysis tools that are now used nationwide in the exam and enforcement program. And when I was there, Valerie started the cryptocurrency working group, and they needed a tech lead who understood the tech and didn't own any coin. So I raised my hand to volunteer because that's part of being in the government, is getting to be in that room and to, help people to really understand the potential. And I was really happy to see that the SEC and the people that were in there really did understand the potential that this immutable ledger provided from a regulatory point of view. The ability to make sure that no one can cook the books is tremendous. Yeah. Then from there, I went to JP Morgan, where I was on their Haskell R&D group, where I met my co-founders Stuart Popejoy. This group very quickly turned into their blockchain center for excellence. Him and I, my co-founder, built Juno, which is the first private blockchain that JP Morgan ever made and open sourced. We deployed it, and really you can think of it as JP Morgan Coin version 0. When we were there doing all this market research, we had this huge collection of questions that we knew needed to be answered. How do you make these things scalable? How do you upgrade smart contracts? How do you make an executive able to actually understand the contracts? How do you integrate it with a existing back office? And we had all these questions, and we had all this experience, and realized that JP Morgan wasn't the right place to push the envelope for emerging technology. So we left and founded Kadena, because we wanted to see if we could answer these questions, and we did.
Awesome. Yeah, I mean, I have so many questions because you've come from both like the regulatory side, then you were on the banking side of it. So it's just a unique perspective to be able to come into this space from both of those, because, both of those are kind of the major concerns in this blockchain space is, how do we comply with regulations and make sure that, we're building something that makes sense, that's legal. Then on the other side, how do you scale it? How do you apply it, when it comes to banking technology, and what are the implications of that? So what were the major conclusions that kind of led you to Kadena and what you're working on?
I think the first one was that smart contracts needed way more R&D. When we were at JP Morgan, Stuart, my co-founder, built I think it was the first version of the EVM in Haskell. It's called Masala. It's open sourced. He actually got challenged by one of our common friends who was his first hire on this desk to go and build this thing on his vacation. So my co-founder being Stu, went to the beach and came back with an EVM interpreter. He wrote a program to parse the PDF yellow paper into like 80% of the program. Still don't understand how he did that, but it's impressive. And he comes back and he says, man, this is never going to hit production, because he has experience building production systems in finance. His background is also pretty interesting because he's the main designer of our smart contract language Pact. His background at JP Morgan before I met him and before he was on this desk was rebuilding a trading platform that sales traders use to now make $30 million every year. And when he was rebuilding this system, it's a quantitative trading platform. The way that it gets used is that a trader gets called by an account, one of their clients, and their client says, I want my portfolio to do X, Y, and Z when the market does A, B, C, but more complicated than that, but a quantitative strategy. He made a system that not only he redid the whole back office and back end so that it would be much more performant, but he actually gave these sales traders who aren't programmers but are nonetheless technical, he gave them a descriptive language for describing these strategies, to the extent that now you have sales traders who will live code most of the strategy on the call with the client. Call and it ends, they go and they finish the strategy up, it hits QA in 24 hours, and then it's in production 48 hours later. Now, for people who have a background with tech, you're going to think, holy crap, you have non-engineers building software that's running in production with hundreds of millions of dollars of money at stake. That's a big deal. And he learned a lot from how to shape a language to make it safe. So then after that, he basically took 3 months off to go and learn Haskell because he was interested in it, and then came back to this research desk. And that's where I met him. So when he did the EVM, he already had this background of deploying a language into production for transactions that is designed for safety, and kind of lucidity is the word that we like to use. It's obvious how the thing works. It makes it hard for bugs to hide. And between that and building an EVM, you just knew, you know what? We're going to have to do something from scratch. We're going to have to go to first principles and rebuild it from the ground up.
This episode of HackerNoon is sponsored by DigitalOcean. Join a community of over 3.5 million developers learning how to build and scale high-performance web apps on the simplest cloud platform. With a flat pay-as-you-go pricing structure and monthly caps across all global data centers, DigitalOcean makes it easy to get the computer resources you need without the billing surprises you get from other cloud providers. Discover why developers love DigitalOcean and get started with a free $100 credit at do.co/HackerNoon. Full-stack developer Austin Pocus.
We're using it to host a discourse site. So basically they give us a machine and we run a Dockerized instance of discourse on there. Gets a few clicks and discourse is ready to rock. With DigitalOcean, they have a marketplace where you just click, I want discourse, you provision a droplet, and you're good to go.
Interesting. Because, I mean, there's so many different challenges when you're dealing with blockchain tech and smart contracting. I was in an event with a bunch of lawyers and we were talking about, how you can use this tech in the legal field. And, a lot of the conclusion all the lawyers were coming to is I have to go learn how to program now because I'm going to be out of a job in 10 years if I don't. And that's kind of a reality. I think that's going to, face a lot of different industries, especially as we move towards automation. But at the same time, if you're writing languages like the one you're working on that are easy to learn for executives and lawyers and different people like that, that changes the entire game because now they can just focus on an easy to learn language rather than having to, go learn, Ethereum or some of these other blockchains.
Absolutely. And one of the cool parts of focusing on legibility and learnability for and ease of use for these non-programmers is that you end up in the situation where the computer also has an easier time understanding the code too, because you've boiled down, you've taken away so many of the places where there could be something that isn't obvious. And by doing that, we actually found that we could do formal verification and be first to market with user code formal verification. We demoed it, I think, 2.5 years ago at this point. And user code formal verification, this term gets thrown around a lot. But what it means is it's really like the goal for a lot of projects in 3 to 5 years is to have this feature. And it's the ability for someone to write a smart contract and then to describe how they intend that smart contract to work, and a computer to take their code, turn it into math, take that intention, turn it into math, and then check your math for you and search the infinite space of possibilities to see if there's any place where that intention gets violated. This is not future tech. This is something that exists right now. If you go to pact.kadena.io, you can actually see a live demo in your browser of code being formally verified. It's the first thing that pops up. And this is kind of another core thing that's important because you can only get so much safety. Humans are humans. You need a computer to be checking your math.
No, absolutely. And in the case of smart contracts, I was joking with the lawyer example, like, what's going to happen to the legal system? Is a judge going to be sitting there and the lawyers are going to be like arguing, well, in line, 3,122 of this contract, your variable didn't execute properly. And, is that the future of contracting? But I can definitely see how creating an interpretive language makes total sense to be able to solve some of those bottlenecks and some of those challenges so that, now they're not going 3,000 lines into code for smart contracts.
Mm-hmm. Yeah. And actually there's, you make me think of something interesting that I've run into kind of in my past there are a couple other examples where you have people who aren't programmers becoming very proficient in a language. They're rare, but they happen. SQL is really the best one, where you run into advertisers, marketers, salespeople who go and learn SQL. This is the database query language. That is a domain-specific language that is focused on how do you query multiple tables to derive meaning from them or derive data from them. And I've run into a number of people who are technical, but they aren't engineers, who are really good and build enormous queries because they use it as their day-to-day job. And then the other example is kind of Excel. You run into lawyers and accountants and traders who are insane at Excel. The stuff you can do with it is crazy. And I've seen entire trading desks and almost entire small boutique banks or shops running on one central Excel file. So, and that is a method of programming. It's just a little bit different than how we're used to. So it's not impossible to get lawyers to kind of meet lawyers and executives halfway. It just takes intention. You need to be really focused on having your language being really good and obvious at what you need it to do, and taking away all the places where you would normally be able to inject bugs or to be able to miss a spot.
Yeah. And Tony, have you had a chance to start to learn some of this? Like, is this, are you starting to understand the programming language? Have you been able to work with it a bit?
Somewhat, yeah. It's both the challenge and the opportunity of being somebody who identifies as non-technical around so many folks who are really pioneering this. And so we are already started building tutorials. And so I get to be a test subject for all of it and really say like, okay, wait, that makes sense, or I'm not quite following. I used to work in Silicon Valley. One of my first startups was with Max Levchin at Slide. And so I would occasionally do very small commits, merge them. And sometimes they would have errors and everybody would be like, wait, who did that? And I was like, oops. And fortunately now I'm really excited with PAC that formal verification and other things will really help to mitigate that.
Awesome. Well, I'd love to ask about the scalability side of things. Maybe, Will, you could give us a perspective on how you guys are solving that challenge.
Sure. So Pact, our smart contract language, runs on a couple different consensus protocols. The one that I think we should really focus on, especially for this conversation, is Chainweb. This is our parallel proof of work architecture. We presented it at Stanford Blockchain Conference a couple years ago and have been working on it since. It just entered testnet. The core concept is pretty simple. Imagine instead of there just being a single Bitcoin, you have two that are running in parallel. With the normal Bitcoin, when you make a new block, it points at its previous block. With this parallel Bitcoin, when you make a new block on one of the two chains, that block points at its previous block and that of its peers. So it points across the gap between the two chains. And now this means that to do a 51% attack or to try to undermine the network in some point in history, you need to fork both chains starting at whatever block you're focusing on. Mm-hmm. So it also means that your security actually ends up going up because now you have two blocks at the same height versus one. So it means that you have to effectively, quote unquote, get lucky with this hashing attack more often, which makes it harder. For the people who have more of a statistics background who are listening, it's just kind of basic law of large numbers. The more samples you have, the faster you converge the true distribution. And the hash rate is this global kind of source of entropy that you can go and sample from. And you also end up getting more throughput because now you have two chains running in parallel, so you get double the bandwidth. And you end up getting also more decentralization in this weird way because the difficulty for each block is half of what it would be if there was just one chain. So there are more blocks being made by more people, and the difficulty per block is actually coming down. That means that the energy use stays the same. The throughput is now double, and the security is now increased, which really undermines this notion of the trilemma that you hear a lot when people talk about Ethereum and their scaling foibles. So Chainweb is this idea, but generalized. We figured out how to use graph theory to braid, instead of 2 or 3 or 4 chains together, tens to hundreds to thousands. We entered testnet at the end of March 2019, and we are running a 10 braided chain parallel architecture. We plan to be releasing the next version of testnet in a couple months, and that will be running 10 chains, and then it will hard fork to 20 chains after some period of time, with mainnet eventually launching some point probably in the early fall of 2019.
And what kind of transactions per second are you looking at?
So this is always the question that a lot of people ask, and they say, "Oh, well, your testnet, it only runs 10 chains in parallel, and each chain does 10 transactions a second. So, okay, you're doing 100 transactions a second." And I'm say, "Yeah, we are." But here's the thing with Chainweb: once you get it to work, braiding effectively anything starting at 10, you have this ability to hard fork to bigger configurations. So instead of it being 10 chains, you can say, okay, I block a height 1 million. We're now going to have 10 new Genesis blocks that are for the 10 additional chains that are being put into the network. We're going to have a 20 chain network. The difficulty of all of the block gets halved. The block reward gets halved, and the energy use stays the same. Your throughput's now doubled, and your overall and the actual security increases. So we're going to launch probably between like 100 and 500 transactions a second, which is between 10 and 50 chains. But as congestion increases because people are using it, and adoption means effectively just congestion, and fees start to go up. Anyone who's a user of Ethereum for any serious business knows the pain of, I have a smart contract running on Ethereum, 2 ICOs that I don't really care about are running on Ethereum, and now the fee per transaction is $10. And this business process that I was running on Ethereum now costs $10 per step, and it's just this huge problem. So as adoption increases, that's what motivates Chainweb to hard fork to bigger configurations. It's all about aligning the incentives of the 3 core users of the platform. You have miners who want more adoption. They want a bigger network doing more transactions a second. You have users who don't want to pay high fees. They want high security, they want decentralization, they want trustlessness, they want openness, but they also don't want to pay fees. And businesses who want to know that if they start using this platform and they start congesting the network because, think Cryptokitties. It launches and then Ethereum gets clogged for a week. They want to know that the network can grow to support the throughput that they now need because they found their product market fit. Chainweb aligns all 3 of these because the answer is, when the need is demonstrated, hard fork to a bigger network.
Mm. And what are some of the use cases that you're seeing on the business side of that component? Because really, at the end of the day, I think that's where a lot of this stuff actually comes into application. Is how are major enterprise companies going to leverage the blockchain and what you're building?
So we're working with several different companies and multiple different verticals. We effectively have a big play in everything from insurance to banking to the next generation of consumer finance to medical to supply chain. So the use cases are really focused on this notion of a hybrid blockchain that we talk about. So Kadena, it kind of cut its teeth on the enterprise blockchain side. We built our system to be able to support the gnarliest, most sophisticated enterprise workflows that you can think of, because we knew that if you don't start knowing that you can support those, you won't be able to grow the network to be able to support them later. It's the problem that Ethereum hit in enterprise, is that Ethereum was built for public use cases for tokenization. And when people tried to take it and actually use it inside of like JP Morgan, for example, the language just wasn't designed to support their needs. I mean, just as things as basic as upgradable smart contracts and having error messages when things break just aren't part of what you need to make a token work on a public side. But in enterprise, you need these things, and you just can't get anywhere without them. So we're all over the place, have partnerships, and have been working on with these various partners for over 2 years at this point. We're in a couple Fortune 500s. We have some small startups. Probably the best way to think about this hybrid use case is a company called Remedy that we're working with. They are effectively a bootstrapped startup that has a Ethereum-based application for medical data that's running right now in Mongolia, and is going to be coming to the US, and they need to redo their entire stack because their current solution just isn't up to the task of dealing with both HIPAA compliant smart contracts and the throughput that they'll need. So we're working with them on helping them to move to this next generation of architecture off of, I think they're using Quorum for their previous one.
Okay.
So, and what they use this hybrid approach for is that the public side is going to have a smart contract that is effectively like a gateway or an API. Think of it like a shopping cart almost on the public network. And there's going to be this private network that runs on our private chain, which right now is Scalability, that runs a lot of the more privacy concerning parts of the application, including encryption at rest and decentralized replication, all these things. And these 2 different parts are linked by effectively like a server and Oracle, but they're linked in a way that allows the trust from the public to extend into the private and allows the private to be guarding the security of the data that they find or the data that they're collecting in a way that is compliant to some of the most stringent regulations, which are HIPAA.
And do you have any favorite use cases that you're seeing or that you think or predict that blockchain will be able to solve?
The ownership of data I think is a good one. So Remedy is one of my favorite ones to talk about. Security tokens I like. I think that they are really more leading towards enterprise adoption or enterprise use cases, because as people start to figure out, okay, what are we going to securitize with these security tokens? A lot of the time, they're things that big enterprises own. And that kind of leads into, oh, well, why are we just securitizing this asset that the enterprise has? Why don't we also use a private or hybrid blockchain to solve some of their other business needs and incorporate that into the solution? But overall, where I see the whole space going is a sharing economy, an enterprise sharing economy. This is one where you're redefining how consumers and businesses interact. I don't really think that we're going to see how the definition of a corporation is changed over the next 5 years. I think the corporations have been around for a long time, and that they probably represent a reasonable way of organizing people. That being said, the way they interact can be dramatically influenced. So one of the things that you can't do with any of our competitors' technology is the ability to have a smart contract that can import another smart contract on a public network in a way that's safe, where if that imported contract blows up, your contract doesn't blow up. Where if that imported contract gets, let's say, upgraded to do something malicious, it doesn't affect your contract. Because this then allows you to have what are called effectively smart services, where you can have an API or a contract that's providing data or providing an integration to some real world physical processing system. Think getting a FedEx shipping label, for example, to another contract. And it's doing this for a fee. This was one of the two things that Ethereum was supposed to be able to do when Ethereum launched. It was tokenization, which they nailed and made many billions of dollars on, and smart contract interop, which they abjectly failed at. Parity multisig is all the evidence that anyone needs. Parity multisig is still a problem, and the Twitter war about whether they're going to upgrade or not is still going on. Mm-hmm. And it's a very simple thing that is impossible to happen in our system, where you have a multisig contract that is the parent contract. It gets imported by a bunch of instances of that contract that are locally owned, and then someone pokes the parent in the wrong place and it blows up. And now everyone's wallets are locked up, and there's still $200 million in there, and no one can get it out. We don't have that problem. When you make that instance, that child, you snapshot the code from the parent. So if someone breaks the parent, that's fine. You still have your own copy, because the code that you put on chain and that you test and that you formally verify and that you've reasoned about and thought about and sweated about and worked on for months or weeks, that code, no one else should have the right to change that code. What you put on there should be sacrosanct. Now, people can say, if I'm importing someone else's code for some service, that service can say, you know what, I don't want to sell to you anymore. You know what, I want to actually increase the fee, and I don't want to use, and it's my contract, so I don't want to use that service anymore. That's okay. But no one should be able to break your contract in such a way that you can't go and move the money anymore.
So it's essentially data isolation for smart contracts. Is that correct?
Closer to code isolation, I would say, okay. Where a lot of the times, like the way it works in Ethereum is when you import a contract, you just jump to that contract and then you execute the code that's there and then you come back. But there's no way to reason about that jump. Mm-hmm. So you can't just say, oh, I'm only ever going to jump here and then nothing else is going to change. That code has state, and if that code has state, then it can break. The way that we do it is when you, instead of doing that jump, we just copy, paste into yours on chain. No one can affect it. You're the only person, because we have upgradable contracts, you can define how you go and you change the way the code is running, but no one else can touch it.
Awesome. So I got to ask, since this is the HackerNoon podcast, what is some time in your life that you've had to hack something well?
So most epic hack has to be at the SEC. This was me probably cutting my teeth as at least a mid, if not a senior engineer. We needed to build a forensic data analysis tool. And because of how the SEC worked in politics, the only tool that we had to use was Excel, specifically VBA. It was the only language that I could use for about a 9-month period. This resulted in me going a little bit crazy with VBA. I now know the compiler incredibly well. And for people listening who don't know what VBA is, it is the scripting language that comes with Excel. It is not a good language. It's quite bad. There's no there's almost nothing nice to say about it. And it's not really that well documented, and it's not really that well supported, and it has a lot of constraints. It's not meant for anything super complicated. But we needed to do this. We needed to get billions of rows of data to be processed, filtered, and set up in such a way that we could then run 160 automated reports on it. And I needed to do it with Excel. So I took SQLite, which is still one of my favorite databases of all time, and I love the backstory of why it exists. Shoved that behind Excel using VBA to stick the two together. Brought in a whole encryption suite. It turns out there's one of those that's just kind of running around that you can paste in. Then added monads to VBA, which got kind of weird. I was in a Haskell phase that actually it's not a phase because I'm still in Haskell now. And Kadena is an all Haskell shop. So I added monads to it and all of these other weird ideas, and ended up with this 30,000 line VBA app that we deployed to 1,000 desktops around the nation, and has worked and has actually been finding real stuff on behalf of the SEC when they go and do exams. This has now all been deprecated, and they have upgraded to better systems. It allowed me to help to modernize the SEC's IT department. They didn't really have much in the way of approved software at the time. That has been fixed. It took years, but has been fixed. And now there's new versions, and they're much better, and they're way faster, and they run on the supercomputing cluster we built. But there was a period of time where my job was to hack the crap out of Excel, specifically VBA, and make it do things that it was just not designed to do. It would lock people's computers for a day because that was the best that I could do, but it worked. The thing was a freaking tank.
That's crazy. That's definitely one of the more unique hacks we've had on the show for sure. I couldn't even imagine trying to hack Excel to do all of that. That just, yeah. And then you're using third-party tools and your own database, and
it was nuts. But you would never run into it outside of the government because it's the only place where you're going to get that crazy of a combination of restriction.
Yeah. Well, awesome. Do you guys have any final thoughts before we wrap up?
Tony?
Just to say, we're really thankful to the HackerNoon community. All of us at the office are constantly reading, and so we hope to be able to get feedback also on Pact and Chainweb Testnet now that it's live.
Awesome. Any other final thoughts, Will?
No, I just want to echo those. Big reader HackerNoon. Really looking forward to when people start really taking a hard look at Pact. There hasn't been a lot of innovation in smart contracts over the past couple of years, and Pact is weird in that way, where it's going to make you think a little bit differently. And I'm really looking forward to, having a much larger community's feedback on it. And maybe the last bit is that, besides just thanking you again for having us on, is that there is because I've actually read about the Lisp machine on, I think it was a few HackerNoon posts. Every once in a while, there's one about this old school piece of tech. Chainweb is, through a certain lens, a giant multi-threaded, multi-tenanted Lisp machine, because Pact is a Lisp and Chainweb is a multi-threaded execution environment. So you can kind of think of it as the grand return of the Lisp machine, where we're going to try to bring this back and fix the last 15 years that we kind of went sideways on, and maybe JavaScript should have looked more like a Lisp. And
where can people find you?
Best place to find us is on Kadena.io. You can find our newsletter there, our Discord. We're out and about, especially in New York, at events, and I think probably our Twitter as well, which is at Kadena_IO.
Awesome. Well, thank you guys for coming on the show. It's been a pleasure.
Thank you so much.
Thank you.
This concludes another episode of the HackerNoon podcast. I'm your host, Trent Lapinski. Please don't forget to subscribe to us on iTunes and YouTube, and follow us on social media. You can also find us at hackernoon.com and podcast.hackernoon.com for more episodes. Thank you for listening.